Hello everyone, my name is Gaurav Gupta and today we will make another machine learning project which is laptop price prediction. Here is the data set. Here you can see we have different parameters given to us. Let me show you all. So here we have different values, laptop name, status, brand, model, etc. We have to predict the final price, this column, of the laptop based on all these parameters like touch, GPU, storage type, etc. As you can see, the final price column, it is having continuous values. So it is a classic regression problem. So let's start coding. Firstly, we will import all the necessary libraries. So import NumPy as NP, import pandas as PD, import OS, import cbond as SNS. Then we will import from sklearn.metrics, import mean squared error and mean absolute error. Then from sklearn.linear models, we will import lasso, sgd, regressor, ridge regressor. Then from sklearn.svm, import svr, from sklearn.preprocessing, import standard scaler and also label encoder. Then from sklearn.ensemble, import random forest regressor. Now we will import from sklearn.gaussian process, import Gaussian process regressor, from sklearn.gaussian process dot kernels, import dot product and white kernel. From sklearn.tree, import decision tree regressor, from sklearn.neighbors, import kneighbors, regressor. From sklearn.neighbors again, we will import radius neighbor regressor, from sklearn.model selection, import train, test, split and randomized search CV. So let's run it. Now let's get the file path. For this we will use for dir name, comma underscore, comma file names in os.walk slash kaggle slash input. For file name, in file names, print os.path.join dir name and file name. Let's run it. Here you can see we got the file path. So let's start with the data preprocessing, for which we'll first import the data using pd.read csv, and then we will copy this path. Let me copy it, and to see the data we will first do data.head. Now let's run it. Here you can see we have all the data. You can also see there are some nan values. It is also mentioned in here, especially the GPU column. So we will take care of it, don't worry. Now first we will see all the columns. So I'm printing the columns, data.columns. Now we will use the label encoder to encode all the labels. Equal to label encoder. Then we will first drop the laptop name, because that does not affect what the price will be. Access will be 1 and in place will be 2. Then for data storage type, that will be changed, and we will use lb.fit transform data storage type. Same thing we will do for the touch. Equal to lb.fit transform data. Then for the CPU, then for the model, same thing for the brand. We are just converting all the text labels into numbers so that we can deal with them easily. Then the status, now we will look at the GPU column. Here you can see it is showing that we have null values, and we can't process null values in whenever we are training our model. It will throw some errors, so we have to remove that. For removing that, first we will access the GPU column and we will fill all the null values with no, because if the GPU is not written or not given, I'm assuming that there is no GPU present. So then mean value for screen, for screen size, then we will replace all the null values in screen. So for this we will specify the value parameter first, which will be uh, mean value, and in place will be true. Then we will have to assign labels to the GPU. lb.fit transform data GPU, and then I'm printing data.head to visualize what our data has become. So here you can see we have no text column now. We have converted all the text into labels so that we can deal with it easily. Now to get even more insight about the data, we can use this method data.describe. We will run it and it will give us some basic information about each column, the number of entries and their mean values, standard deviation, minimum. You can see that. So now let's move on to data visualization. For data visualization, I'm using SNS dot pair plot function, which will be data. So we have run this function. Now this takes some time because it is kind of heavy to plot every pair in the table. It depends on the data you are given with. So yes, it can take some time. Here you can see it is taking some time, but no issues, we can move on. So here you can see we have all the plots. So it is looking tight, but you can change them accordingly however you like. I like this because here you can visualize all the data and all the correlations in one graph. So yes, here we have our pair plot. Now to visualize even further, we can also use sns.heatmap, and we will pass data.core function. So we will run it. Here you can see the correlation of different columns with each other. Let, let me, yeah. Here the column names are given, the color schemes are given. From this you can judge how much the final price is affected by RAM, storage, GPU presence or absence. So here we can see that. Here you can see RAM, storage and GPU has prominent effect on the final price. The final price is kind of directly proportional to them. So it's a good way of visualizing the data. Now let's move on to scaling and splitting our data. So first we will get our data. For y, we will divide our data into two parts, and for x, that will be equal to data dot drop final price, and axis will be 1. Then we will use standard scaler. X will be std dot fit transform x, y will be std dot fit transform y, and y equal to y dot travel. You can skip this y dot travel part, it's just for avoiding some warnings. There, that's not a big issue, but again it's good practice to use this. So let's divide our data into training and testing. Y train, y test will be equal to train test split x, y. Test size will be 0.2, means 20% of data will be test data, and random state will be 0. Now wait a minute, let's run it. Now we will define two arrays. First is MA, second is MS. It will store mean absolute and mean square errors of the different models which we are going to use right now. So I'm also defining short names for mean squared error and mean absolute error. Absolute error. Now let's code our function, which is model training and score. It will take a parameter named model, then it will fit the training data, then we will get the predictions from it. Model dot predict x test, then we will print the mean square error, then we will print mean absolute error, Then we will append both of them to their respective arrays. Then a dot append. Now let's run it. So now our function is there. So we will define our model, which will be random forest regressor. N estimators will be 5, and then we will use the function model training and scope, and we will pass the model. Now let's run it. Here you can see we have the mean square and mean absolute error. So we will do the same thing for each one of the models. Now we will code our second model, which is lasso regression. Lasso alpha will be 0.1 and model training and scope will be model. Now let's move on to third model, which is support vector regressor, which will be model equal to SVR, and then model training and scope model. Now let's move on to our next model. Wait a minute. Which is a stochastic gradient descent. So for this we will use the SGD regressor, and then we will copy the same line. Then for Gaussian process we need to first define our kernel, which will be dot product plus white kernel, and then we will define the model, which will be Gaussian process regressor. Kernel will be kernel and random state will be 0. Then we will run it. Now let's move on to our next model, which is decision tree regressor. So simply decision tree regressor, and now the seventh model, which is k nearest neighbor. And lastly we will code our model, which is reg regression model. So reg, and alpha will be 1, then model training ends. Now with all the models you can see that we have the least amount of error in this random forest regressor. So we will optimize it further. What we are going to do now is parameter optimization or hyperparameter optimization. So let's start with our hyperparameter optimization. For this we first need to select our model, so it will be model selection. Now we will define various parameters and various ranges for each parameter actually, so that we can experiment with multiple values. For x in np dot length space, start will be 200, stop will be 2000, and num will be 10. Then max features will be either auto or square root. Then max depth will be int x for x in np dot len space, not line space, it's len space 10 comma 110, num will be 11. Then max depth dot append none. Then min sample split. Min sample split will be 2, 5 or 10. Min samples leaf will be 1, 2 or 4. It should be samples, not sample. Then bootstrap, it can be true or it can be false. Then min weight fraction leaf will be 0, 1, 2 or 3. Then random grid will be a dictionary. Here we will map every parameter we have defined every to the values. Then max features, then max depth, then min sample split, then min samples leaf, then bootstrap, then min weight fraction leaf. Now let's run it. And we also, let's print first the random grid so we can verify. So here you can see we have different values. Wait a minute. Here you can see we have different values for each parameter. Now it will check best values of the combination of each one of these values to get the best model it can get. Now let's start with our model which we have to optimize. So RF will be random forest regressor, and then RF random will be equal to random used search CV estimator is RF param distribution, like the parameters on which we have to test the model, which is param distributions. It is the random grid we defined in above cell. Then how many iterations we want, an iter will be 100, CV equal to 3, verbose will be 0. You can use any value for verbose. Random state will be 42 and n jobs will be -1. Then rf dot random dot fit xtrain and ytrain. Now let's run it. Now this function usually takes time If you are using grid search CB, it will take even more time and you have to wait for a long time. Again, the time is dependent on the number of parameters we have to optimize. Number of parameters we have defined here. If we have defined less parameters, it will be finished in less time. So don't worry, let's wait for a minute and let this code take its time, because it will give us the best model which is possible. Here if you see this warning sign, you can ignore this, because I checked it and it is not affecting us much, so I left it. You can solve it or try to solve it. I would recommend, if you want to solve it, check it. It will be a fun exercise for you. But if you don't want to, don't worry, it is not a big issue. Now the code is complete, so now we can move on to the next step in this, which is best model training and score. So it is best model training and score. So let's start coding. First we will get the best parameters, which we will get by rf random dot best params. We will run it. Now with these best params, we will define the model, which is random forest regressor. It will be n estimators equal to params n estimators. We can also visualize params, so first we will also visualize the params. Now here you can see we have all the parameters and their values. You can copy it from here, but I prefer this because sometimes these values change when you run it multiple times. Depends on multiple factors. So yes, it's best to use this approach, because here you will be sure that you are using the best parameters given by your code. So let's copy this first. Now we will move to our third parameter, which is min sample split. Then min samples leaf. Then max features. Then max depth. Then the last parameter, which is bootstrap. Now we will use our same function, model training and score. Now let's run it. Here you can see we have improved our scores. Let me plot the graphs first so that you can visualize it even further. So let's move on to the last section, which is plotting losses of different models. Now let's start the code for plotting. First we will define a variable known as bar width. Then we will import matplotlib.pyplot as plt. Then we will define a fig variable, which is plt.subplots. Fig size will be 16,8. You can change it. I am preferring 16,8. Now we will define the variable br1, which will be np.arange. Length of the mean square errors array. then plt dot bar np dot a range, not range, it will be a range, length ms, color would be green, you can use again any color you want. Width will be the bar width which we have defined above. Then label will be mean squared error. Then we will do br2 which will be x plus bar width for x in br1. Then plt dot bar br2 ma, color will be purple, width will be bar width, label will be mean absolute error. Then plt dot x label will be models, and the font size will be 16. plt dot y label will be loss with font size of 16. Then we will define an array of models. It contains the name of every model: random forest, lasso, support vector, stochastic gradient, Gaussian, process, decision tree, k nearest neighbors, ridge regression, and then best model. Then we will set xtex which will be r plus bar width for r in range, length ms, dot models. Dot models. No, it comma models. Then plt dot legend, not big legend, it will be simple legend. Then plt dot show. Now let's run it. Now here you can see all the accuracies of different models for random forest, lasso, support vector, machine, so stochastic gradient, and the last and the final best model which we have optimized. Here you can see that the most effect we have is on mean squared error, not on mean absolute error. Yes, mean absolute error have also gone down, but yes, mean square error has shown the bigger impact, but that's not an issue until we don't increase our error. So overall we have reduced the error from the best model, which is a good thing. So we now have our best model for the prediction of laptop price. So this is the last part of this project. Hope you like this project. If you like this, do share, like and subscribe to my channel for more such projects, and do also comment what you want to see next, and with which technology. So thank you for watching my videos. Thank you very much.